Welcome to this explainer, where we're going to demystify the overwhelming and, frankly, sometimes totally chaotic landscape of energy meter certifications. Seriously, if you've ever looked at a spec sheet and felt completely lost in the weeds, you're in the exact right place. Today, we're mapping out exactly what applies where so you can confidently navigate this crucial terrain.
Okay, let's just dive right in by asking the big question on literally everyone's mind when they're staring down these massive regulatory spreadsheets. How many certifications does it actually take to turn on a smart meter? It sounds like the setup to a joke, right? But the reality is, it's a deeply complex web of safety, accuracy, and security mandates.
Here's our roadmap for today. We're covering 1. Navigating the compliance maze. 2. Hardware, accuracy, and safety. 3. Communication and interoperability. 4. The cybersecurity landscape. And 5. Mapping the ecosystem.
Let's jump straight into part 1, navigating the compliance maze.
When you look at the source data for these standards, the sheer volume of acronyms is just staggering. We've got IEC, ISO, MID, OIML, CSPR. I know, it looks like a total alphabet soup right now, but I promise we're going to make sense of these acronyms together. A really great way to think about this is to treat these standards like stamps on a passport required for your meter to operate. Some of these stamps are absolutely mandatory for every single trip, while others depend entirely on your destination and what you're actually planning to do when you get there.
Moving right along to part 2, hardware, accuracy, and safety.
Okay, so here is the mandatory foundational triad for hardware. Think of these as your essential passport stamps. First up, general requirements via IEC 62522-11. This ensures the meter can physically survive harsh environmental stresses out in the real world. Second, we have the IEC 623 series, which ensures billing accuracy. I mean, this is the whole point, right? It prevents customers from being overcharged and utilities from facing massive billing lawsuits. And third, product safety via IEC 625-23-1. This guarantees electrical safety, ensuring the unit doesn't, cause a fire hazard in someone's home. These three are absolutely non-negotiable and anchored directly to the physical box and its internal firmware.
So the crucial takeaway here is distinguishing between standards that only test the physical shell versus those that heavily scrutinize the internal metrology. On the left side, we have hardware-only tests. Think of the IEC 60068 series for extended environmental qualification, or the IEC 602059 series for long-term durability. These are pure physical stress tests. But on the right, standards like the IEC 602053 series for accuracy don't just care about the plastic casing. They vigorously test the interaction between the physical sensors and the internal firmware that's actually calculating the real-time billing data.
But wait, depending on your destination, you might need some conditional visas for your passport too. Utilities often demand custom utility type tests to meet their specific regional needs. If your device emits electromagnetic fields, you'll definitely need EMC emissions clearance like CIS PR11 or 31. If the meter uses wireless RF modules, which, let's face it, is standard today, you must get radio certifications like FCC, RED, or CE marks to ensure you aren't jamming up other frequencies. And finally, legal metrology approvals like MID in Europe or OIML depend entirely on local government regulations.
All right, let's shift gears into Section 3, Communication and Interoperability. If your smart meter is going to communicate across the network at all, IEC 62056 is the absolute mandatory language it must speak. This is the DLMS/COSEM standard. What's absolutely vital to understand here is that this standard spans the entire chain of communication. It doesn't just apply to the firmware sitting inside the meter, it's also heavily applied to the head-end system, the HES, and the meter data management system, the MDMS. Basically, everyone across the entire grid has to speak exactly the same language.
Now, what if the meter isn't just a passive measuring device? What if it's a prepaid meter? Well, for prepaid systems, these two standards are absolutely essential. IEC 6205531 dictates the actual prepayment functionality within the meter itself. But just as importantly, IEC 6205541 handles STS, or the Standard Transfer Specification. This ensures that tokens bought from completely different vendors are fully interoperable. It's a really elegant solution because it ensures consumers can always top up their power at the corner store, totally regardless of who generated their specific token.
Which brings us to Section 4, the cybersecurity landscape.
This is arguably the most rapidly evolving part of the whole roadmap, as utilities fight off increasing cyber attacks. On one hand, we have DLMS Security Suites 1 and 2. Because they're part of IEC 62056, they mandatorily lock down the communication protocols in the firmware and the head-end system. They basically make sure the data packets are safe while in transit. But on the other hand, system-wide standards like IEC 62443-4-2 and ISO 27001 are increasingly required. These don't just look at the individual data packets, they protect the broader device and the entire overarching system architecture from malicious, grid-wide attacks.
Finally, let's wrap things up with Section 5, Mapping the Ecosystem. Look at how the burden of cybersecurity passes down the line here to create an unbroken chain of trust. It starts at Step 1 with the meter manufacturer, building securely under IEC 62443-4-1. Then, in Step 2, the system integrator takes over, guided by IEC 62443-2-4 to piece the systems together safely. And finally, in Step 3, the utility or asset owner takes the baton to manage the live grid operating under IEC 62443-2-1. And notice that ISO 27001 is the shared heartbeat required across all 3 steps. That ensures total alignment from the factory floor all the way to your neighborhood power lines.
Even the digital glue holding the network together requires specific security clearances. Whether it's the data concentrator unit gateway, the head-end system, or the meter data management system, each and every product is governed by specific slices of the IEC 62443 standard, right alongside DLMS. This ensures that a hacker can't just bypass the lockdown meter and attack the gateway instead. Simply put, there are absolutely no weak links allowed in modern network architecture.
As we wrap up this explainer, I want to leave you with a vital question to consider for your own smart meter deployments and certification journeys. Is your current infrastructure truly future-proofed against evolving cyber threats and environmental demands? Because understanding this roadmap isn't just about compliance for the sake of it. It's about building a robust, safe grid that actually lasts. Thank you so much for joining me on this deep dive. And hey, keep this roadmap handy the next time you're looking at a smart system design.